Hello YouTubers. In this video I will observe another group of organization blocks, called cyclic interrupts. You are already familiar with the word cyclic from the first video of the organization blocks. It is OB1, cyclic execution block. Cyclic interrupt OBs differ from the cyclic execution block. As you remember, cyclic execution block OB1 is executed cyclically by the operating system. Its execution time depends on the size of your program, so its cycle can vary. Depending on your instruction, it may vary a lot. This block has a lowest priority, so it can be interrupted by any other OB, so its cycle can increase dramatically. When things come to time-sensitive processes, where precision takes over, you are in need to use very accurate time stamps. Here comes cyclic interrupts. For example, you want to calculate speed of the conveyor, and accuracy is critical variable, then you are in need to use cyclic interrupts. You measure the count of the encoder pulses every 100 milliseconds, and after some math stuff you can get an accurate speed. Using OB1 accuracy will vary. For that kind of tasks, Siemens has 9 cyclic interrupt OBs, starting on OB30 and ending on OB38. Each of these blocks has its own default interval. For example, OB30 interval is 5 seconds. And it will be called every 5 seconds, doesn't matter where OB1 will be at that moment. So, when the exactly 5 seconds passes, the OB1 will be interrupted by OB30, and will be executed the part of the program that is within OB30. So, as I already mentioned, Siemens has 9 cyclic interrupts, and they are with default intervals. Let's take a look at the default intervals and priority classes of cyclic interrupt OBs. OB30 interval is 5 seconds, and its priority class is 7. OB31 interval is 2 seconds, and priority class is 8. OB32 interval is 1 second, and its default priority class is 9. OB33 interval is 500 milliseconds and its priority class is 10. OB34 interval is 200 milliseconds and its priority class is 11. OB35 interval is 100 milliseconds and its priority class is 12. OB36 interval is 50 milliseconds and its priority class 13. OB37 interval is 20 milliseconds and its priority class is 14. And last one, OB38 interval is 10 milliseconds and its priority class is 15. By using cyclic interrupts, you need to take into account that execution time of the cyclic interrupt must be significantly shorter than its interval. If the runtime of cyclic interrupt is greater than its interval, then operating system will try to call same cyclic interrupt OB, while it's still in execution. You may run into the endless loop. To avoid that, time error OB80 will be started, and reports the error. But, the cyclic interrupt that caused the error will be executed later. Besides the priority and the interval, there is another important parameter, called phase offset. What the phase offset is? Let's say you are using more than one cyclic interrupt in your program, it's OB35, with interval of 100 milliseconds, and OB33 with the interval of 500 milliseconds. Eventually, the start execution of these two different cyclic interrupts occur at the same time, and you will run into big problem. Time error OB80 will be called. To avoid this happening, you can specify a phase offset. Phase offset ensures that the execution of a cyclic interrupt is delayed by a certain time. Now we know the interval, the priority class, and phase offset. Another thing you need to take into account, that not all the CPUs support all the cyclic interrupts. You need to refer to the specifications of your CPU. Depending on your CPU, parameters for the cyclic interrupts can be changed with Step 7. Just open your project hardware configuration, properties of the CPU, and switch to the tab Cyclic Interrupts. Here you will find out all the cyclic interrupts that are supported by your CPU. Mine supports only one, OB35. All others are grayed. Also, I can change only execution cycle from default 100 milliseconds to something like 250, or so. As my CPU supports only one OB, then phase offset is not needed. I will leave default interval. Let's try our cyclic interrupt in action. I will write a simple program that will save time of each cyclic interrupt in the data block. Here I have data block with counter and 20 records of time of day variables. I will save the time of 20 executions of the OB35. Import OB35 into the project, open it, and write the code as follows. Let's try to test it. To start the test, the counter needs to be set to 0. As you can see, we have saved 20 records, with exact interval of 100 milliseconds. Let's clear our records, and start everything over. Same result again. Let's change the interval. Now it will be 1 second. As you can see, this time interval between saved records is 1 second. Let's make a short conclusions. Cyclic interrupt OBs interrupt your program at fixed intervals. The equidistant start times of the cyclic interrupt OBs are determined by the interval and the phase offset. Runtime of each cyclic interrupt OB must be significantly shorter than its interval. Execution of the cyclic interrupt organization blocks can be disabled and re-enabled with a delay by the help of the system functions SFC39, SFC40, SFC41, and SFC42. Let's upgrade our code, so our program could disable execution of our OB35. For that purpose, SFC39 is going to be used. Let's see how it works. Reset the records, and restart the counter. Now let's try to disable the execution of OB35. As you can see, it stopped. To restart it again, we need to use SFC40. Let's try to restart the execution of OB35. As you can see, execution of the OB35 was successfully resumed. That was a brief overview of cyclic interrupt organization blocks. If the video helped you, do not forget to like it, and subscribe to the channel. Thank you for watching and happy coding.